Great. So really enjoyed the whole morning, and the last couple talks really set up mine nicely. So I'm remember what you heard, and I'll try to build on that. So I'm going to talk about the bioeconomy in net zero world. I'm at a place called the Union of Concerned Scientists, and as you might imagine from the title, one of the things we're concerned about is climate change. And I'm in the vehicles program, and so I focus on fuels, and I just recently did a big report on how fuels are changing, kind of the fuels we use today, the fuels we may use in the future, or are using, and will use increasingly in the future. And I won't go over this as much as I'd like to, but this is sort of the punchline, which is that the gasoline's getting dirtier, but our alternative fuels are getting cleaner, and there's a lot of potential for them to get much cleaner than they are today. I'm going to focus on the, because this is a bioeconomy talk, I'm going to be talking about biofuels and the bioeconomy. We've had a lot of different perspectives of what the bioeconomy is. Since I'm thinking about how to fuel a clean transportation future, naturally, I'm focused more on that. But I want to think about how that fits into a net zero world, and in particular, like how do we do that? How do we clean up our fuel system while we protect and enhance land-based carbon sinks? Because I think those are increasingly important part of what we need to do to get to a net zero world. And so the outline of my talk, I want to talk about the importance of net zero for the bioeconomy and how that I think is getting more prominence recently. And then how the products of the bioeconomy, we can expect them to evolve as we move towards deeper decarbonization. And really thinking about not just the products themselves, but the feedstocks and the landscapes that supply those products. And then I'll close with some thoughts on a bioeconomy, what it looks like when a bioeconomy is sort of in balance. So, of course, at the Paris climate agreements, the world got serious about cutting emissions to below 2 degrees C, shooting for 1.5 degrees C, or at least trying to figure out if that's possible, what that looks like. But a subtle shift, I think, but an important one, is sort of instead of focusing entirely on decarbonization, the concept of net zero, getting to net zero by mid-century, and as Tom said, subsequently negative shortly thereafter. And I think this chart is a way to kind of think about what that looks like, right? We're familiar with the idea of these blue bars representing the emissions, having to come down. But now we have the idea of these yellow bars, the negative emissions, really taking carbon out of the atmosphere. Those need to rise, and they need to keep rising considerably, and they become as big a part of the story as the emissions reductions as we move forward. And so those anthropogenic greenhouse gas sinks, those are things. This is a little chart put together by some folks at the Center for Carbon Removal, right? Those are things like forests, and agriculture can be a sink depending on how it's practiced, and bioenergy, carbon capture and storage, which I'll touch on briefly, and then of course taking carbon out of the atmosphere by chemical means and putting it in geological storage. And so I guess, but a simple way to think of this is on the top part we have our kind of low carbon products, and I think that's what the bioeconomy has been focused on, right? How do we provide the products that everybody needs and do it with less emissions? But the yellow part here is really a different thing, which is how do we provide carbon removal services? And I think the bioeconomy can do both, but they're different products and they have different implications. And so of course the products that I'm thinking about mostly when I talk about the bioeconomy, clearly I'm recognizing that the word means different things to different people. But we have our ethanol and biodiesel, electricity produced from wood. But when we think about what it takes to get to a net zero economy, we really have to move away from combustion for transportation, for most of our energy generation, and has already been referenced. That's not going to happen overnight. There are opportunities to, for renewable energy to be a growing share of the transportation fuel pool and high octane gasoline blends, for example. But that's in a context where gasoline use has to be falling dramatically. So, and it's not going to happen at the same pace for every fuel, right? So we've also had a lot of discussion about aviation fuels potentially sticking around for longer. But in the long-term trajectory, I think we're looking at a lower demand for these low carbon products and a bigger demand for carbon removal services. So I want to just touch on what this carbon capture and bioenergy carbon capture and storage, BECCS, which is, this is the chart from the paper you referenced. The idea that when you collect a bioenergy feedstock and you process it into a product, you also collect some CO2 and sequester that underground. And when you do that, you can have a carbon negative pathway. And depending on which product you're selling, you'll have more carbon leaving the facility and going back into the atmosphere, or more carbon going underground. And so there's a sort of variable balance there of how much are you in the low carbon hydrocarbon business and how much are you in the carbon removal business. And so if you sell hydrogen, if you sell electricity, if you sell heat, you can put most of the carbon underground. If you sell jet fuel, you may be able to put some of the carbon underground. But a lot of it's going, obviously, probably not being captured at the back of the jet, as we heard. But one of the interesting things about this paper is that they found that in their model of how to get the West Coast to a deeply carbon negative electricity system, they found that the offsets, the carbon negative credits, were more valuable than the electricity that was produced. And so, I think that's the theme I want to touch on here is, today, clearly we're in a market where, low carbon, high octane fuels or something look like an attractive proposition. But as we electrify the transportation sector, the value of these offsets is likely to become a big part of this story. And not just kind of incremental value, but, how do we find them at a very large scale? And what's the role for the bioeconomy in that? And so, of course, this is some of the easiest stuff. So the easiest places to get pure CO2 are from a fermentation process. And so there's a pilot project with this ethanol plant where they're already capturing and sequestering some CO2 from an ethanol fermentation process. And of course, we have bioeconomy products people have talked about a lot that aren't combustion products, right? That aren't burned, but that can be recycled. And so, these things are underway. But, just the beginning, I think, of an important trend. So I also wanted to touch on feedstocks and landscapes because when we think about the impact of the bioeconomy, and in the fuels world, we've really been spending a lot of time thinking about that because it's such a large market. So what's the impact on food crops, on corn, on soybeans? And we're already today, about 10% of our gasoline is ethanol, and that's consuming about 40% of the corn before co-products, and so that's 30 million acres of some of the most productive land in the U.S. And we're using about 25% of the soybean oil to make biodiesel, and so when you look at where that's grown, that's a big part of our productive land, and I don't think there's an opportunity to take more and more out of that sector. I think I don't need to argue that. There's I think a lot of agreement about that, and so there are other opportunities like agricultural residues, right, is one that has come up several times. These are the bales of corn stover that are being converted into ethanol at the Poet DSM plant in Iowa. And of course, when you use agricultural residues, you can make more product without increasing the footprint of agriculture. But there's still a question there because one of the places that we are looking to increase carbon storage is in soils. And so, when you harvest stover, you have to definitely consider, you're producing more of these products above the line. You're producing more low carbon fuels, but what are you doing to the carbon balance in the soil? And I think there are some good agricultural strategies to make sure that you can protect soil, water quality, other things as you use residues. But those adjustments are important, and the thing that's important really is to keep your eye on both balls, right? Not to only think about the products that we're removing from the land, but also to think about the condition of the land, the carbon storage in the land, and of course it's really about much more than carbon storage, water quality, soil health, other things. But so if we think about, okay, so that's the ag land, and what we're taking from it now and what we might take in terms of residues. But there's a bunch more land, and this has already been touched on. Some of the land that's in pasture now is, perhaps an opportunity. And this has been touched on a lot, right? This is a picture from Illinois of the miscanthus, which can put a lot of carbon in the soil at the same time that it's producing a high yield of products. And so it can really serve both the carbon sequestration or carbon removal market and the low carbon products market at the same time. And I think that's what makes this a particularly attractive strategy. And this is a little out of date because there's a new, this was based on the previous billion-ton update, but I think the basic geography is close enough to make my point, which is that the location of this perennial bioenergy is sort of out of the Corn Belt. This is where it looked economically competitive, and a lot of that, I think, is pasture land. But there's another thing we can do with some of this land, which also can especially serve this carbon removal market, which is reforestation or afforestation, and of course, so forests can store a lot of carbon, and they can do that without a lot of industrial processing. They're pretty good at that, at least for some period of time, and so the folks at World Resources Institute looked at land which was previously forested but is not now and is not in cropland, and tried to figure out, where is that and what's the opportunity to put that back into forest, and what does that mean as a carbon mitigation strategy. And some of my other colleagues were trying to figure out, like, if you got this done by 2025, what would it mean by 2050? And if you could convert half of I should go over a little. So the orange is the big opportunity here. This is places where there were forests that are not there anymore, but it's a suitable habitat to regrow forests, and they're not in cropland. So if you reforested these areas, you could sequester a great deal more additional carbon by 2050 in a way that would really affect the balance, help you to get to net zero, really offset significant emissions. But if you put that map next to the perennial bioenergy opportunity map, there's a lot of overlap there. So, I don't have an answer that we should do one or that we should do the other, but I think we need to look at both the opportunities to make the products or to sequester the carbon, and really compare what those opportunities look like, that are going to be different. And so I think as researchers, that's one of the things I think is important is a lot of our analyses are framed as, how does the bioeconomy product compare to the fossil fuel alternative? Is it better than the status quo? But that's a pretty low bar to clear, and it raises a lot of questions about what's your counterfactual scenario? What do you think is going to happen if you don't do anything? I mean, a different question that's related is, well, how does the afforestation or reforestation strategy compare to the product strategy? So we're going to do something about climate, but how much should we do in the bioproduct sector, and how much should we do in the carbon solution or the carbon removal side of the ledger? And conversely, I mean, right now we have some very generous policies, at least in theory, that reward you for products that are taken off the land and made into bioproducts. If you add up the value of a cellulosic credit and a low carbon fuel standard credit to make a fuel out of corn stover, it looks like a lot of money per ton. You can't get that money to reforest some of these areas. So I think we need to make sure that the policies also recognize and reward, not necessarily with a single instrument, but both kinds of ways to achieve these carbon goals. So, but I don't think it's a zero-sum game, right? So I think there are some trade-offs, but I think there are opportunities to do this that are pretty smart. This is a picture of, well, I'll get to that in a minute. So when you look at things at this scale, right, and you say, oh, look, in Iowa they just grow corn. But some work that I think is quite interesting is, when you really start zooming in. This is a paper recently by some folks that really zoomed in and said, look, this is a state that produces a lot of corn. But even in this state, even in the middle of it, where corn's a dominant crop, if you actually look at just one field, you see there's a great deal of variability. And when you look at this detailed scale, you see there are opportunities for what I think they're sometimes calling precision conservation as opposed to precision agriculture. So we can use the same kind of knowledge base about yields, about economics, to say not just where should I put more or less inputs, but where should I stop planting corn and plant something else? And you can be smart about this both from the perspective of saving money, but there are also some real environmental benefits. So this is some other work from Iowa where they looked at, if you're really smart about where you take land out of row crop production and put it into perennials, you can see really disproportionate environmental benefits. And so they found 10% of land, if it's placed correctly, can have 80% improvements in some of these very critical water pollution and erosion problems in this region. And so I think when you put those things together and you start to think about, well, we have a landscape dominated by one crop, but if we take some of the land which is particularly valuable not for production but for conservation, we can get with a small. So these are some nice visualizations that another folks at Iowa State put together that I think are very helpful to kind of imagine this. So this is like what 8% looks like, and that's where you see these really big conservation benefits without a big hit in terms of land area for producing crops, especially if this turns out to be not particularly the most productive land. But we don't need to stop there because, and so this is a picture of this STRIPS project, right, where they're kind of putting the certain parts of the watershed in prairie grasses. And I should say, but you don't need to stop there, right? We can increase the amount of perennial cover because what we know is that Iowa's spending probably at least 32% of the crops being produced in Iowa are going into the bioeconomy now to make ethanol and other fuels. And they can make lower carbon fuels and start to contribute more to carbon sequestration, other environmental services at the same time. And we don't even need to just stop with the narrowly defined kind of bioeconomy, but of course, some of the same strategies apply to how we produce food and feed and fiber. So I think we can think about how do we start to contribute to both the carbon mitigation potential from land while we contribute to lower carbon products, if we're smart about kind of a more detailed understanding of how we use the land. So just to wrap up, I think as we think about what net zero means, it means delivering both low carbon products and carbon removal solutions. And I do think the bioeconomy can do both. But to evaluate these opportunities, we need to recognize both that there's value to low carbon products and that there's value to carbon stocks that remain in soils. And so sometimes, not only value low carbon things when they enter our energy space, but if we have low carbon solutions in the food space or in the conservation space, all of those, the atmosphere doesn't know how you took the CO2 out of it. The temperature depends on the total. And so obviously there are trade-offs and you can't maximize everything at once, but I think I made the particular case of smart placement of the perennials on diverse landscapes, but I think some of the ideas about how do you use forestry in this space in a smarter way and integrate that into a supply chain, kind of similar, avoiding a kind of zero-sum idea of do you do this or do you not do it, but say how do you do it to maximum benefit. So thanks.